Here again. We're ready to get started. We've got a nice group this morning, or this afternoon for those of you in Europe. So today our agenda is going to be, we're going to start with a brief introduction. I'm going to go through the company or housekeeping rules and a little company overview. And then we'll jump right into the slide presentation demos and some use cases. Then we'll wrap up with a summary, and then we'll have a Q&A section for the questions. So we welcome your questions. And then we'll have some closing information to wrap up the webinar. For our general housekeeping rules that we use for these webinars, these are pretty common to most webinars, but if we'll go through them again. If you have any trouble, use the little chat window over the right in your webinar control panel to send us a message. All attendees will be muted for the duration of the webinar. Computer audio is the recommended option, and there are also some associated materials, some little handouts, some PDFs that you can drag and drop. Got a little pointer there to your little handouts in the control panel. Feel free to, there's some product information and some other useful information there. So post your questions at any time during the webinar as you think of them. Free to put them there, and then we'll answer them at the end with a Q&A session, and then if we shouldn't be able to get to them all, we'll be sure and follow up with email. So for those of you not familiar with Larsen Software, we're based in Houston, Texas. We just moved to a new building, but we've always been in Houston. On the west side of Houston, for those familiar with Houston, we're founded in 1984 as graphics technology experts. We've been technology experts, graphics experts for 20 years. We develop powerful, innovative graphics, end user software, and toolkits based on CGM and on open standards like CGM and SVG. We have promoted the CGM usage for a number of years by providing a free CGM viewer, which was just recently replaced by a subscription version that you can order online directly through our web store. We're the developer of the first HTML5 CGM viewer that eliminates the need for plugins. It allows you to view CGMs in any browser without a plugin. We're a founding member of the CGM Open Foundation. Larsen Software, our technology simplifies the graphics workflow for technical publication professionals like tech writers and illustrators, as well as engineers and geologists working with tech data. So with that said, I'm going to now turn it over to David Manik for the remainder of our webinar, and I'll be joining again at the end to entertain any of your questions. So, David.
Thank you, Don. Good morning, everybody, or good afternoon, or good evening. Thanks for that introduction. I thought it'd be good to start with some drivers. What are the drivers to actually help us to do this webinar? And a lot of it comes from the customers, from you, users or potential users. So just to go through those to begin with. So we've definitely seen an interest over the past year of CGM grow. That has definitely been the case. Sorry, of SVG. So we wanted to try and do this webinar. We did one last year and the year before. So we've got some new content we want to provide you with. So hopefully today you'll find it interesting, particularly around CGM to SVG conversion. That seems to be one of the main drivers. One of the things we've done to help us internally and the developers is to develop a profile called Tech SVG, and we'll talk about that today, what that's about. And it's also in the handouts that Don mentioned earlier on, so you can drag and drop that over to your desktop. So we've stepped up the support as SVG in our products, especially on the import side. We've been exporting for a while. And you should see that with CGM, that it's still being used out there, but certainly SVG provides some more capabilities that CGM doesn't. So there could be some other reasons to use SVG for particular use cases. We'll also look at the pitfalls and benefits of using SVG. I think the ones around CGM are well known, so not much using communicating those to you. And we'll present some use cases that again have come up in the past year. So I think these are going to be the most common ones we're going to find working with different customers. And we also want to communicate kind of our strategy around CGM and SVG. So what we're doing, what we're working on, both internally and really developing products externally that you can use. So hopefully we can get through all that today. So quite a lot to cover. So historically, probably most of the audience is familiar with CGM. It's a 2D graphics format, has a long history in providing quality graphics in different environments. So it's kind of reached a status where it doesn't really need much more doing to it. It works, it does the job. We have the web CGM profile that allows us to deliver vector graphics on the web, and it's managed by CGM Open. So we really have a good stable format to use. With SVG, again, it's probably older than you think it is, but it was primarily designed to deliver high quality vector graphics to the web or for the web, for a web environment. It wasn't designed as a data exchange format, so it was really a one-way street. So it just for display purposes more than anything. So, and that's where I think we've encountered challenges really converting files to SVG and then perhaps bringing them back. So, and I think it's not a criticism of the format. It was just never designed to do that. So a bit of the history of where it came from. It came from a few different ideas like VML, which was developed by Microsoft, PGML, which was like a PostScript format, but the final decision was to base SVG on XML, which is an interesting kind of choice, in fact, because really XML is not really a graphics format. So an interesting choice, but could provide some interesting possibilities for the SVG as we go forward. If you're interested in some more information on the origins, then you can click that link once you get the slides on the origins of SVG. So the commonality, there definitely is commonality between the two formats. Both are 2D, both accredited by the W3C, the World Wide Web Consortium. I would say they're both suitable for creation and maintenance of technical illustrations. They're the only graphical formats widely used for editing vector and raster data, and they can contain both sets of data editable within the file format, which is unusual. And that was mainly done within, say, the technical publications environment, because a lot of older illustrations going back many years were scanned in, and they wanted to reuse those, even though they were probably outdated in the format wise, but to redraw them, the cost would have been huge. So that's why that's one of the reasons why CGM was chosen, certainly by the technical publications community in the beginning. The other thing is they have the potential to be validated. CGM is slightly different, but certainly with SVG, because it's XML, there's definitely the way of validating these files. But also with CGM, people design tools like MetaCheck to actually validate files. Companies like Airbus use that to validate their files when they come into the company. So they are kind of valid CGM. The other thing is that both of them can contain metadata. So when I say metadata, I mean not kind of graphical data, but data that could create like an interactive graphic, like a hotspot. So both have that ability. And SVG also has the capability for animation as well, and it can be data driven, which is really interesting feature of it. So there's some, as I mentioned earlier on, there's some additional things that SVG might give us the opportunity to do. The display also of vector graphics in the web environment is very important, and SVG has native support, which is excellent for getting the graphics into a browser. The only caveat I have around that at the moment is that there's no real off-the-shelf environment, so you would still kind of have to do work to give it the user a good feel of how to navigate around the file. We also came up with our own technology for CGM, which allows us to view CGM files in a web environment without a plugin. So that really gives you the best of both worlds. You could go in either direction, keep your CGMs or go to SVG. So a bit of background on the CGM. Obviously, computer graphics meta file, 2D, not owned, it's non-proprietary, and it's managed by CGM Open, which Don mentioned at the beginning. It first appeared in the 1980s, so really it's been around a while, but it's stable and it's doing the job, so we don't see any issues with it. The W3C accredited the WebCGM profile, so that's all done and dusted, and it was adopted by the S1000D community. So that is now the chosen, still is the chosen file format for delivering S1000D information to projects. But as I said, CGM required a plug-in technology to view graphics in a web browser, which caused security issues and so forth. But if you need some more details on WebCGM, you can click that link at the bottom, again, when you receive the slides. So where is it used? Well, I would say predominantly in the aerospace and defense markets. And probably a lot of the people attending today is from those types of company. But it's also used in automotive. It's widely used in automotive companies as well because of the openness of the format. And also in oil and gas. So in fact, that's where Larsen actually developed the business from, is from the oil and gas industry. He adopted CGM pretty early on as a way of actually data exchange and displaying their data. So why? It's non-proprietary, it's open, reliable data exchange. It has the ability for profiles, and these were developed specifically for industries. So WebCGM, aerospace and defense, oil and gas is the PIP profile, and automotive also adopted WebCGM. So CGM is used for delivery, publishing, and display of graphics. So it's an all-round format. So it could be used really as an archive file. So it could be the source file, could also be the file that's published and displayed. So that is really useful. In the oil and gas, it's slightly different because the use of CGM wasn't really persisting, in the respect it was used like on a one-off basis. So although it was used to bring in data and exchange data, it was probably only used once. Whereas in the technical publications industry, it has to kind of persist. It has to be used again and again for many years. So different use case. So quick background on SVG, scalable vector graphic. As I mentioned, it's XML encoded format. Again, it's a W3C standard. It's managed by the SVG working group, which is part of W3C. And also it has native support in all the popular browsers, which I've already mentioned. So Chrome, IE, Firefox, Safari, all those, as long as they support HTML5, then the SVG will work. So the SVG specification is very, very large, and it's XML based, as I mentioned. The first version to be released was 1.1. There's the full profile, and then there's what they call the tiny profile. It's still pretty big, even though they call it tiny. It was designed really as a subset of the full specification, and it was designed for like phones and tablets, just to reduce the footprint down. But what we found is that technical illustrations only require a small percentage of the attributes in the full specification, and we'll talk about that more in a second. Version 2 of SVG has now been released, but we don't see really any impact over the initial release for the support that we're providing for illustrations. So just to kind of emphasize the XML part of SVG, there's obviously some good benefits to that it's based on this open international standard. It's structured information, so it's there's lots of things we can do with structured information based on the schema. We can have rules and so forth that companies would have to adhere to when creating these files, but none of that really has been done at this time. So the caveats or the warnings: off-the-shelf schema covers the whole specification, so it's not really suitable to validate files because it just encompasses everything. So somebody would have to create a new profile or schema that would be required to validate those files. So we've created a profile, but we haven't created a schema for that as yet. And obviously the main thing is there's no rules for file creation, which could lead to interoperability issues. So at the moment, we're encouraging people still to use CGM and then just export out as SVG. Don't try and use SVG as the source file. So as before, what industries is SVG used in? Well, the main reasons for it being used is ones I've described already. But last time we did this presentation, we didn't mention the aerospace, defense, and automotive, but that has definitely changed over the past year with a significant growth in the use of SVG in aerospace and defense and automotive. But it's mainly for the display of the vector graphics in a web environment, like in an interactive manual. The other place it's used is GIS, or Geographic Information System, so maps on the web, but not Google Maps. It's kind of used in other areas, kind of more vertical markets. If you're interested, there's a vendor called Esri, esri.com, who create software around this industry and using SVG as their display medium. Also, the graphic arts industry use SVG, but I haven't really seen a lot of that on the web. Still, predominantly, you will see PNGs and JPEGs. You'll see raster images. But if they have to view things close up, if there's going to be a degradation in the data by zooming in, then definitely vector data is going to give you a better result. The other area that we see is that data visualization. So perhaps I can bring up this example here. So this is going to launch in Chrome. I just need to move this over. Let me just bring it over to the other screen. So as I move around, you can see the percentages are changed. So the data for the actual graphic is an SVG, but the data is coming from a spreadsheet. So this is really interesting in that we could actually, in theory, drive graphics in the same way. So there could be like a spreadsheet driving what the user sees on the graphic. So some really interesting things we might be able to do with illustrations in the future using this technology, so data-driven. So this at the moment we use more like in a say a portal or something where people need to see kind of data changing or dials or whatever. So different uses for it. So let's just get back to the slides. So I'm just going to go through, the webinar has started, but I just want to try and give you like a mini agenda what I'm going to try and go through. One of the main things is conversion. So we'll go through those topics there. And then a bit on the technology, what we're doing to try and help people convert files and edit files. And then finally we'll look at compliance. You know, how do I comply to standards still if I'm using SVG, perhaps. So the primary conversion scenario that we're coming across so far is CGM exported to SVG, and that's where people want to see graphics on the web, but there's no plugin technology allowed anymore in that browser. So SVG provides the ability to view that graphic without a plugin. So that's what we see as a primary reason that people have migrated to SVG. So it's not as much to replace CGM, it's more as a way of displaying the data without that plugin technology. But there's also now we're getting more people coming in with where the origin data or the source data is SVG. So that's also important as well. Primarily we see this coming through Adobe Illustrator at the moment, where the graphic has been created in Adobe Illustrator, and there's then an SVG file associated with that. And we've got a use case on that coming up. So our experiences of doing these conversions has prompted us to write the Tech SVG profile. So the objective of that was to try and standardize the elements we import and export from our own software, because of as I mentioned earlier, the spec is so large. So we published the Tech SVG profile. You can drag and drop it to your desktop today, or we can go to this link following the webinar. So things to think about if you're on a conversion project, pretty obvious, but if you're not optimizing this process, then your definitely project cost is going to increase. So we really say, like, you need to look at the conversion before you actually start the project, because there could be some things that are going wrong, and we'll probably talk about those as we go along. So converting CGM to SVG. So you can see on the right there, we tried to give a visual presentation of the elements that we see technical illustrations using out of the SVG spec. You can see it's a smaller percentage, but it also is a percentage of both the tiny profile and the full profile. So there's again a bit of an overlap there that we prefer it not to be, but there has to be for certain elements that are used within technical illustrations. So we're really currently optimizing the export, and a lot of this is based on real life customer files. So some of the challenges that you might encounter if you're doing a conversion is file size. So you can remember is CGM is binary and SVG is XML. So potentially you could see an increase in file size. So it's always worth looking into that, doing a test convert, because that can have an impact downstream when you're trying to view this for your users, because the file size is bigger. Embedded raster images. Again, you need to look at that, because that could impact on file size. Hotspots, are they still going to work when you go into your environment to view? And we'll talk about hotspots as we go along, and also line styles as well, and fonts. So kind of common things that you have to always look at when you're converting files. The same applies CGM to SVG. So our strategy is in two parts really. Standardization, and that's why we've written the Tech SVG profile. So that provides those guidelines for import and export of SVG. We've made those publicly available. And what we're really trying to do is create an environment where SVG is interoperable. That's our objective. And then technology, we're updating our software to support the SVG, Tech SVG. So then that should smooth out, at least within our own software, the import and export of those files. And we're also, and we'll talk a bit later on, of developing new products supporting SVG. So what is Tech SVG? As I kind of alluded to before, it's kind of a subset of the full profile and the tiny profile, and we've documented that, so you can download that copy. So we really think it will help not only ourselves and our customers, but perhaps other vendors who want to take advantage of it. We're not kind of forcing it on people, it's a totally voluntary thing. So we've been socializing that strategy. We've been showing that profile to third parties, probably more specifically in the aerospace and defense communities at the moment, and we've spoken directly to them about it. And we're also developing our products to be compliant with it in the future. So again, a bit of a mini agenda, just to talk about those topics in a bit more detail and present you some use cases. And these might help you going forward if you've got a conversion project in mind. So raster images. So as I mentioned earlier, that both those formats are hybrid, so they both support the embedding of raster images. CGM, you're usually going to find TIFF files, because that's really one of the standards that was used for introducing raster images into a CGM file. But SVG does not support TIFF. So there's an immediate challenge. It only supports JPEG and PNG. So if you're doing a conversion, you have to be aware that TIFF is going to be converted to one of those two formats. So I'd always advise to do kind of a sample first, because it could affect the quality in some way or the file size. But that would have to happen as part of a conversion. So it would change really the raster file to JPEG or PNG. The vector elements, though, will not be affected. They will remain the same. If a hybrid file is coming from SVG and it's obviously containing JPEG and PNG, then that's not an issue, because CGM does support those two raster formats. So that shouldn't be an issue coming in the other direction. So hotspots. Hotspots, just to kind of explain what they are if you're unaware, is it's really an attribute that provides a user with an interaction with a graphic. So a bit like you see with a hyperlink, but this time it's specifically within a vector graphic. So this could be like a simple feedback, might be just a tooltip, or it could be more complex, where we have to go to a parts list. So we have a link between the graphic and the parts list, and that might be two-way. So it could be a more complex interaction. The good thing about CGM is it's got a clearly defined method of writing hotspot metadata, and it's all documented within the web CGM profile. Whereas SVG, there is multiple ways of defining hotspots. So this immediately could cause issues going into a viewing environment or an editing environment for that matter as well, because you'd almost have to have a customization for every way that those hotspots are defined. And that's another reason for doing TEC SVG. So why is it important? So is interoperability, and the ramifications could be that your editing software doesn't recognize the hotspot. So how do you edit it if it doesn't recognize it? And vice versa, if the hotspot doesn't work in the editor, it's more than likely not going to work in the viewing environment unless it's been specifically designed for it. So what we've done in TEC SVG is we've created a clearly defined hotspot attribute. So every time we write out a hotspot, it's the same. So this is our first use case, and it's really based around hotspots. So we were given an SVG file, and we brought it into our illustration software, VisXedit, and it contained interactive information. And it was an interactive wiring diagram. So the file opened, and the graphic elements were all displayed. However, like the metadata was not recognized. So it just didn't display as we would do usually with a hotspot information within VisXedit. So we really couldn't edit it within VisXedit. But it was obviously exposed within the XML file. In this case, the interactivity, the SVG itself was created in a software that was specifically designed to work with a custom SVG viewing environment. So even though we have an open standard, we've already got something that's customized to a specific writing of that SVG file. So this is kind of a classic case of interoperability issues and so forth. So what would be the solution to this? We think there's three. First one is we develop VisXedit to interpret the information correctly. So we'd have to kind of develop the software, customize the software to do that. Kind of the argument against that would be is that what if somebody else comes in with another type of SVG with similar information, but it's not the same, and then we'd have to develop the software. So we're actually just keep customizing the software for different uses, which might bloat the software, slow it down, so it might not be a great approach. You could also perhaps use XSLT. If people in the XML world are out there, they'll understand what that is, which is used to transform data. So it might be easy just to transform the data over to something that VisXedit can understand, and then take it back again. Or you could just change the metadata within an XML editor. So that's possible. So if it's just a number change, you could open it in, say, Notepad, do the change, and then resave it. So it really depends on the degree of editing that has to be done. So we think that probably the second and third solutions are probably the most cost effective. But then you might have impacts on the SVG viewing environment. So you might have to transform the data back again into its original structure for it to work. And the third, that might be unworkable if you have to change the location of the hotspot. In other words, the location will be coordinates. So you can imagine trying to change that in an XML editor, and these are like 10 strings of numerals that, or 10 numerals that you'd have to change one thing to actually move the hotspot, which is really unworkable. So the next thing I mentioned about conversion was line styles. And line styles are, again, causing some issues, mainly because the WebCGM defines line styles like dash dotted lines, whereas SVG has no guidelines at all. So actually, to do the conversion, you have to be really careful, because you could actually change the look and feel of the file because of that. It just doesn't understand them. So what we're looking at is actually mapping those over into a line style for that WebCGM has, and we're really working closely with customers to do that. And the other one is the old one is fonts. Fonts always seem to cause an issue, even between other formats, not just ours. So there could be like textual formats where, you know, we haven't got that font on your system, it needs to be replaced, and so forth. But the most common issues is like size, positioning, spacing. So kind of the whole font itself can cause issues. And you can imagine if the size is wrong, it could flow over part of the illustration, or obscure part of the illustration, which might be important. So again, this is really important that we actually get this right when we're bringing the font through. So we have another use case for that. And it was the import of SVG files again into VisXedit, this time generated by by Adobe Illustrator. So the font size was not consistent, and the typeface itself was the mapping was incorrect. So it was coming in really not in the same typeface, which caused issues again. So what we did find, which was quite strange, is Adobe Illustrator does not declare the font size in the SVG, which is strange, or the units that the font size uses. And it uses the pixel coordinates to actually declare the actual font size in the file itself. But VisXedit is expecting the SVG file to declare those units, like could be a point size for the typeface, and it doesn't do that. So, which we found unusual from Adobe. So the typeface, the problem with the typeface is that CGM uses Helvetica and Adobe Illustrator uses Arial. But in this case, it's using Arial MT, which is their own kind of Adobe's own version of Arial. So it's not even standard Arial. So again, there was a mismatch there as well. So how did we solve this problem? So now VisXedit recognizes that this is an SVG file from Illustrator, and it uses the appropriate settings. So pixels are mapped to points, so we're able to preserve the font size. And the typeface, Arial MT, is we map that to the standard Arial, so we preserve the font integrity when it comes through. So we managed to solve that one, but some unusual things come in from SVG from Illustrator. So this is what, again, what we're trying to say is that without any kind of guidelines, then SVG could be written in so many different ways. So I'm now going to just move on to the technology, and we mentioned VisXedit, and some of you users out there might be familiar with it, but it's kind of our native CGM editing environment. But it also supports the import and export of SVG files. So if you just want to move files individually over, then it's ideal. We've implemented the Tech SVG profile into the product, and it already fully complies to S1080A through the CGM format. So you can add hotspots manually and automatically in VisXedit and then export them out as an SVG file, because I've not really seen, say Adobe Illustrator, for instance, not that easy to put in interactive data into an SVG in Adobe Illustrator. And then we could obviously view the graphics in HTML5, view HTML5, the CGM, or you could view the graphics in our SVG in a web browser. So I've just prepared a short demo just to give you an idea of what we're talking about with import and export. So you'll see on the this is a CGM file, so just a spare parts type illustration, and you'll see that it's on the left hand side we've got a tree which contains the metadata, and we've got here some information on the hotspot on the call out here, which is obviously just one of many, but we've got more information on this one, so I want to use this as an example. So we've got a tooltip, grommet, which we've added, and we've also got a link, an external link to another file from this particular graphic. Okay, so to save this as a SVG, it's quite straightforward. As save as, I'm going to save it into this folder, so I can choose the format that I want. We support obviously other formats, but SVG we're using for this particular example. I'm going to save that out. So very quick, it's only a small file. So what I'm going to do is I'm going to open that file firstly in Notepad, well, Notepad++. So you can see now that we've got the XML structure of this SVG file. And I'm going to find that hotspot had an ID of hot001, so I should be able to find that down here. So this is what I was talking about writing out the hotspot in a standard way. So we kind of based this on the way that CGM writes them. So we have now a standard way of writing out the hotspot data, which is consistent. So you'll see hotspot 2 down here has the same structure to it. The only difference is this has a link, an external link to it. Okay, so I'm going to take the same file now. I'm going to open it in Chrome. So I'll just double click on it. I'll just have to drag it over to this window. So now we have the SVG in the Chrome browser. So no plugin. And we should see that the tooltip grommet is working. The other hotspots will work. And this one has a particular link, which links us to another, in this case, SVG file. So we have a simple link between the two. So the only downside, as we mentioned at the beginning, is there's no real environment for this SVG. So you can zoom in and zoom out using the kind of the keyboard here. So I'll just zoom down. Quality is good, but you'd have to kind of design a viewing environment around it. So the good thing is now I've got this SVG, is because we've been working on this import, that if I go back to VisXedit Let's just close this down and open. And I'm going to open there. So I've chosen SVG. There's the one I created. It comes back in, and you'll notice that the hotspot information is still there. So we've kind of made this file interoperable. More work to do, but I think we're making some really good progress. So let's just go back to the slides. Just conscious of time that we want some time for some Q&A. So the other thing we do is we do batch conversions of files as well. So I would say VisXedit is really good for converting individual files, but we also have VisX Transform and convert CGM to vector that converts CGM to SVG. Transform, though, actually will do both ways. So it will convert CGM to SVG and vice versa, SVG to CGM as well. Plus, it will also do auto hotspotting as part of the process, which can save a lot of time. If you've got a project that needs hotspots, you can do those very quickly, and you'll have a fully interactive illustration. So a very quick demo of Transform before we get to the Q&A. So I'm just going to bring that up here. So what we have here is a way that we can choose the files we want to convert, and they can be all sorts of different formats. So these are all CGM files. If you're familiar with S1000D, these are all their graphics for the demonstration manual. I choose it where I want it to go to. Then I choose the file format I want to go to, in this case SVG. And then we can just start the process. So here's all our files. And this is a really quick process. So we're converting all the CGM to SVG. If there was no hotspots as well, then it would hotspot if we wanted to, all the callouts. And that's pretty much done. So very quickly, we've converted all those files, and we've retained hotspots if there's already there, or we've created new ones if required. So we have a lot of customers out there using this for different projects, either in just using the GUI that we've seen there, or you can also use it as a command line to do conversions on the fly. So if you want more information on Transform, there's also a handout you can pull off the that section. So what we're going to do in the future. We've got some, I think we've got some really good ideas. One of them I've kind of alluded to already is that we really like to create an environment for SVG viewer, like an SDK that will allow you to kind of create an environment to view SVG files more intuitively with toolboxes you might be familiar with from the CGM world. And that's something we're definitely thinking of doing. The other idea is, at the moment we're actually editing SVG illustration files in VisXedit, but we perhaps see a way of creating a more specific tool and then leveraging the SVG format and the power of the XML file. So it's still open, but it could be, we could have data-driven graphics, we could have validation, we could have styling through style sheets. So we see there's a lot of scope for this in the future. So just some ideas that where we might be going. Finally, compliance, which is kind of always a topic that for many of you in the audience is an important one, because you have to deliver data to a customer, to the government. So both formats, as we mentioned earlier, are standard, they're open, they're ratified by the W3C. CGM is still the format documented in the S1000D spec. Issue 5 has just been released of S1000D. It's not changed. CGM is still the required format as a deliverable. it doesn't mean to say you can't use SVG as a mechanism to display files, but if you're delivering to a customer, then that is still the format that is required. And this is also true probably of the ATA as well, although they've adopted S1000D as well. So yeah, things may change in the future, but that is the current status of compliance. And if you're interested in the S1000D spec, then these are the chapters you really need to look at, because this is what's been written about the CGM format, about interactivity. So really, if you're interested in that, then, or you're delivering a project around S1000D, then those chapters are really applicable to you. And finally, so this is the profile, the web CGM profile that you still have to save as to deliver that CGM file to your customer. So will it change in the future? Not sure, but it's a lot of work to do if they were to change it. So just to summarize, we're making some significant progress supporting all graphic file formats, not just CGM and SVG. We're doing, we have a lot of thoughts around PDF as well, which is important to a lot of companies. So stand by for some news on that as well. So our keywords are the 3 C's: conversion, compatibility, and compliance. And we'll continue to develop standards compliant technology. That is our main goal. And we do that by employing lessons learned from the customers, from you and your files. So files or graphics coming from customers are really key to us developing the products and making sure they work. So as you've seen on the roadmap, we're looking at SVG as a way of going forward with different tools, and we'll be really pleased if companies want to work with us on some of their implementations and the Tech SVG profile. So with that, I'll bring Don back in just to help me with some questions. And I've got one at the top here. If I right click, do you see the source XML? I'm assuming, Don, that is alluding to the.
Yeah, that came up during your VisX edit. Yeah, of course it would be showable, viewable in the viewer, but I think the ask was asking about, is it viewable in VisX edit while you're editing the SVG?
Right, okay, yeah.
And the answer to that is no. It's turned into a internal binary format, so no, it's not visible. The XML representation is not visible at that stage.
Yeah, it is. I've just shown it in Chrome, though, that if you do a view source in Chrome, you do see the XML in there. Any plan to display SVGs in VisX View HTML5? Probably a question for you, Don.
Yeah, that's certainly along the lines we're thinking, like a SVG viewer toolkit that would be kind of harmonious with the HTML5 viewer, and working with the Tech SVG hotspots and metadata through a SVG toolkit. So yes, there's thoughts along that. No, we're certainly open to input on that.
Okay, the next one is, will the presentation be made available? Yes, you'll get an email tomorrow, which will give you a link to our SlideShare site. So definitely you'll get that. If you don't, then please email me and I'll send you a copy. Okay. Have you developed any part of the SVG standard for a toolbar for zoom pan etc. That kind of takes us back to what you've just said, Don, about an SVG viewing environment, I think.
Yes, that's right. That's along the lines we're thinking. Like that's one of the things that's kind of missing in your off-the-shelf browsers. You can render a SVG in any of the browsers, any of the CGMs or SVGs that we do. You can render them, but then navigating them is that's kind of application dependent. So we're thinking of that's along the lines we're thinking for a toolkit, so that you could have an illustration navigation toolbar.
Yeah, kind of the one thing I spotted the other day is that there's actually a zoom tool appears in Chrome where you can use, but I think it's more of a kind of an internal thing for any kind of web page. It's not specifically an SVG tool, zoom, because it actually zooms the whole thing up rather than, keeps the window kind of the same size, and then you zoom in and it gets bigger within that window. So so that's really, like Don says, we'd really like to have an environment that enables people kind of off the shelf to get a similar environment to CGM viewing. I'm just looking at another question. Is it possible SVG could replace CGM in the S1000D specification? I suppose it is possible, but probably Don will remember the work that he put into the web CGM profile and getting that accepted into S1000D, and the amount of documentation that's required to do that, along with the documentation of the specification itself. So you could question is that that it would be a very kind of big task to do that. So probably don't see that in the near term happening. Although there is an attractive part to it, is it's XML, which is the kind of data modules and so forth are XML as well. So it kind of makes sense, but there's a lot of work to be done to make that happen. So Don, what would you say is a major challenge working with SVGs? Are those the ones we've already gone through, or do you see anything else that's a big challenge for you working with that format?
Well, yeah, we've touched on some of them, like there's not a consistent viewing environment for them. That could be accomplished through toolkits, and like we've talked about, interoperability is really the elephant in the room when you're talking about SVG. It's like you pointed out initially, it wasn't designed as an exchange format, which is so important to the aerospace and defense industry example, where the major manufacturers worked with hundreds of component manufacturers, and this all needs to come together with some common format and common exchange rules. And that's certainly not, with SVG designed for a broad, very, very broad market, broad application, it's just not there for that specific community. So, but like you say, stay tuned. There's possibilities.
Yeah. So I think that's it for the questions. I'd really like to thank everybody for those questions. Excellent. It's good to have some.
Dave,
sorry, go on.
Excuse me, we had one more question.
Oh, sorry, yeah, we did. I didn't see that come in. SVG issues equals plain SVG speed, slow, parse data sets. What about SVGZ? Well,
SVG, of course, is just is an SVG that's been essentially gzipped with the zip compression. It parses, it decompresses very fast, so it doesn't put. It makes the file size smaller. If you've got large SVG files that have to be transmitted over the web, it certainly helps with that. So yeah, the compressed SVG does help with file size where that's a bandwidth problem. But it doesn't speed up the rendering any. As a matter of fact, could slow it down slightly, but it doesn't. They're actually rendering and zooming. Once you get it in the browser, then you decompress, and the browser is working with an SVG DOM. It's internal binary format. So yeah, hopefully that.
Yeah, I think that does answer. Yeah, so just to summarize, it reduces the file size, but it doesn't improve the performance of rendering the actual file in a browser. So
Yeah,
but it will
right.
it will decrease the footprint, the file size footprint. Okay, thank you. Yeah, we have discussed this before, and we've done that particular the compression format. So thanks for that. Thanks for that question. So I think that is it for questions. Sorry about that if I kind of rushed ahead. So yeah, I'd just like to thank you, Don. Just some closing information. You can obviously discover some more information about Larsen software technology at cgmlarsen.com. We've actually registered a new domain name as well, which is active. It only takes you to the same site, but it's svglarsen.com, so you can use either one. There'll be a link to a recording in the email that's sent tomorrow, and that will also have a link to the slides. So somebody mentioned seeing the presentation, and you can download it and see it from there as well. You can follow us on LinkedIn and Twitter. Predominantly we post on LinkedIn now, so if you want to follow us, just follow that link there and you can get the latest information. If you want to meet us in person, don't be put off by this is a user conference, but this is October 21st to 24th in Tucson, beautiful location for the Eagle Logistics Connection conference. This is the Raytheon Eagle, so perhaps some of you will be there, but it's a really good conference in general if you want to learn about the whole gamut of kind of technical publications and not just graphics. And again, you can contact us via our email addresses, obviously. So thanks, Don. Thanks for attending. And I've just had another question through, quite a long one. And perhaps we'll take that offline if you don't mind. We've got a copy of it, so we will we'll definitely respond to that offline. Sorry about that. So thanks again for attending. Stand by for another webinar in October, and we'll send you details when it's scheduled. Thank you very much.